Hi everyone, my name is Wilson. I am a PhD student at UNESP, São Paulo State University, and I'm here to present our work, SADIRE, a context-preserved sampling technique for dimensionality reduction visualizations. We know that dealing with high-dimensional data is one of the essential aspects of analytical and automatic tasks. And to understand the patterns of high-dimensional datasets, we often rely on dimensionality reduction, which can be represented by scatter plots after reducing to 2 or 3 dimensions. Here, closer points encode similar data samples, right? And this visual representation has some visual scalability issues that can be addressed for many techniques, by many techniques. However, these techniques must account for the preservation of the similarity relations used by the dimensionality technique, the preservation of the outliers to understand critical aspects of the datasets, and the preservation of class boundaries to understand class separability, as for example, when we are analyzing a dataset used for classification. So that we introduce SADIRE, which is a sampling selection technique that accounts for a visual scalability of scatter plots, metaphors. And our technique can be used as a pre-processing approach for constructing scatter plot-based visualization. The workflow of SADIRE works as follows. First, we define a grid on the visual space, right? In this case, in the 2D space, in which each data point is inside a cell. Then we measure the density of each cell to then use a redundance removal approach to retrieve only the important data samples. Our redundance removal approach works as follows. We start by the densest cell, which is the center of this window. Then we aggregate all the neighboring cells according to this window and select only the data point inside the center cell as a representative. That is, here is the second densest cell. We use the cell size K and the window size alpha to aggregate all the neighboring cells and return only the data point inside the center cell. At the end, we will have a result like this, using a fixed K and a varying number of alpha, that is, the varying number of window. With SADIRE, we can select the data points with preserving similarity relations and preserving context. We also select the outliers so that users cannot be deceived by the visualization. Notice that the class boundaries are also preserved in the visualization as induced by the dimensionality reduction technique. Besides this result, we also numerically evaluate our technique according to coverage, redundancy, and runtime execution. We also conduct a user experiment on the perception of visual disorder and similarity relations. We ask to refer to our original paper for more details. This work was funded by FAPESP. Thank you very much for watching.